Hello and welcome here from Ars Electronica Home Delivery. Today inside Futurelab, we are broadcasting here from our Ars Electronica lab area, and today's topic will be BioArt, and I'm happy that Yoko Shimizu is here. She is a key researcher in the Ars Electronica Futurelab, and she is working in the field of BioArt for a long time. And I'm really happy to have your talk here and learn a little bit more about what you're doing, which projects you are working on, you have worked on, and all the things you're doing in your key research topic. Again, of course, you are invited to post your questions, your comments on our YouTube channel. And of course, we will make afterwards a short question and answer session where we, of course, pick your questions and bring them to Yoko, and Yoko will try to answer them, of course. So thank you very much for watching, and Yoko, this is your stage.
Thank you very much. Hi everyone, thank you for joining us in the Ars Electronica Home Delivery. Today we're bringing you the program from our BioLab in the Ars Electronica Center. My name is Yoko Shimizu. I'm an artist and researcher at the Ars Electronica Futurelab. In the Futurelab, we work with a lot of client corporations from around the world and develop creative, innovative technologies that combine art, technology, and society. And today, I just wanted to show you a little bit of our BioLab. Our BioLab has two floors, the upper floor and the lower floor. The upper floor is more like a museum gallery environment, as you can see here. And then the lower floor is more of a lab environment with tools and equipment for the researchers to work on their research projects. So first, let's take a look at our upper floor, the museum and gallery section. So Ars Electronica has a global community of researchers and artists and scientists that are working on cutting-edge biological projects. And we showcase their latest projects in this section so that we too can learn about what is happening in the world of biology right now. Let me show you an example of a biomaterial that we have here. This is cellulose created by bacteria, and we process them with laser as well. So this is laser cut and laser engraving on bacterial cellulose that was cultivated in a nutrient solution and created by bacteria. The interesting thing about the Ars Electronica Center is that we have different types of labs in one building. For example, right next to the BioLab, we have the materials lab. We also have the AI section, for example. And this collaborative environment allows us and the Futurelab to collaborate different types of researchers and develop something truly creative together. So let's go around and then go down into our BioLab. And on this side, we also have different types of bio design projects if you're interested. And we also always have info trainers with us in the BioLab. So if you have any questions when you visit us, you can always talk to them as well. So let's go down to the lower floor. Here we have all the equipment and tools that are necessary for basic biology experiments and research. For more advanced research, we do work with our local universities to create something more state-of-the-art and complicated. And next, I would like to show you some of the BioArt projects that I have been working on using some of the slides and images that I compiled together. Are we? Okay, so if you can see the screen, I first wanted to talk about biology and chemistry. So since I was a child, I've been in love with nature and all living things. I would go out in the field, in the mountains, and collect leaves, seeds, insects, and make sketches of them. And I wanted to learn the beautiful mechanism of how all living things work, as well as how nature and the universe works. So I studied biology and chemistry in the university so that I can understand how they work better and perhaps come up with creative expressions that can be utilized in art and design. In the lab, I also did a lot of field work, which is going outside into the wild, collecting specimens, and coming back into the lab, analyzing and also cultivating different things. In the biochemistry lab, we would cultivate different types of cells or microorganisms, and I was fascinated by the beauty in which living things emerge and then proliferate, expand, and then it kind of goes into a chaos where you cannot no longer control them anymore. But I always love the fact that in BioArt, you start with something that you designed, but in the end, when you co-create with nature and living things, end up with something that you didn't even imagine, and it's much more beautiful than something that you could have created on your own. And I've cultivated different types of bacteria, microorganisms. They all create different, very unique, interesting patterns. And I like that in this small petri dish, which is only about 10 centimeters in diameter, but there's this entire microcosmos where life begins, expands, and eventually deteriorates and dies. And you can observe the beautiful cycle of life in this small world. And there's also a lot of research on designing art materials or design materials using biological methods. And one material that is often created is cellulose made of bacteria. As you can see in this picture at the bottom, there's a water tank, which is a nutrient solution. And then you put the mother bacteria into that solution, and it would gradually start to create a membrane on the surface, which is like a translucent, which looks like a translucent skin of some kind. And then you can take that out and dry it, and then press them and process them in different ways. For example, like I showed you before, use laser cut or laser engraving. You can also color them with different materials so that you can create anything that you can imagine with other art materials that are currently available. And you can even combine these materials with mechanical parts, for example, audio parts, and then create a speaker, and also play music with what you have cultivated. So this is footage of the speakers that I created in the lab, in my studio, which is playing music. Another type of co-creation that I really like is creating something together with plants. Plants are the foundation of our food chain, and it has a lot of different properties and characteristics that are so interesting and beautiful. And this is a project called Photosynthograph, where I create high-resolution prints on the plants using photosynthesis. Different types of black and white films can be created and attached onto the plants, and then you expose them to the plant cultivation lights. And it goes through a chemical reaction process using iodine. And as you can see in the picture, you can create very high resolution, accurate images on the plants. And this is a movie that is a time lapse of the chemical reaction process. I'm always fascinated by the beautiful transition of the chemical reactions that occur all around us in nature, inside our bodies, and inside the plants. And as you can see in the end, the typography biodesign appears on the leaf. This is another project that I've been working on, very passionate about. It uses Gravitytropism, and this is an installation inside the gallery where I was cultivating growing lots and lots of tulips, hanging them from the air and suspending them in mid-air and letting them grow. And as you can see, that the tulip is turning 180 degrees very accurately and gradually growing upwards. Now that we are in the stage of commercial space flights and colonization of Mars, and there's so much, a lot of projects occurring in the space area, in space flights. And I think as a biologist, I'm also very interested in how life can be maintained outside of Earth, and how can we cultivate different things and grow things and create an environment or an ecosystem outside of Earth as well. And this is a project that plays with gravity, Earth, and plants. And you may think that plants are not moving at all or moving very much during the day, but they actually are sensing the environment very accurately and adjusting themselves throughout the day and moving around. And by controlling that movement or co-creating with the plants, we can create beautiful installations and also accurately control the angles of the way they grow as well. On the upper slides, you can see the tulip turning 180 degrees very accurately and growing upwards. And on the bottom slides, you can see the tulip first growing up and turning 180 degrees. And then I flipped it during the growth, and then it turns back and turns again 180 degrees, creating an S shape. And you can also create perpendicular angles, as well as turn them 360 degrees and create a live tulip bracelet, for example. This is a footage that shows one tulip that is hanging and turning, and you can see the strength and the beauty of these plants as they grow up into the air and defy gravity. And this is another one that is turning 360 degrees and creating a loop. And as you can see, there are so many things that you can do when you create with other living things or create with nature. I hope that everyone will be interested in BioArt, and we at the BioLab will also be able to provide you more and more content on what we are working on in the BioLab, as well as what you can do at home and what kind of workshops that we provide here, or what kind of projects, corporate projects or large-scale projects that we are working on in the Futurelab. So thank you everyone for listening, and I look forward to your questions.
Thanks a lot, Yoko, for this wonderful talk about your research topic. And we have the first questions via YouTube. So hopefully we can answer. You can answer it?
Yes.
The first one is quite interesting. Hi Yoko, these works look awesome. I was wondering if you have some kind of safety guidelines that you follow to allow manipulating and exploiting bacteria with no harm to human health.
So a lot of the bacteria that I use for exhibitions are very safe bacteria to begin with. For example, yeast cells. Yeast you usually use in baking, for example, or there are a lot of different types of bacteria that are used in food products. And those kinds of bacteria that I try to use in our exhibitions or my exhibitions, and I do agree safety is the most important thing when you're working in bioart or biotechnology. And if you are not familiar with this field, or if this is the first time for you to work in this field, there are community labs throughout the world that have, and also our biolab here, where they have professional researchers with a biotechnology background or chemistry background that can help you figure out what kind of protocols that you should follow. And there are academic researches also on how to provide community labs in a safe way. And I also hope that I will be able to conduct that kind of research in the Ars Electronica Center as well, so that we are providing this beautiful, wonderful technology to the public, but in a very safe and ethical way.
Wonderful. Another question, what was the largest scale project with this kind of material you are using?
So I think the tulip installation, where I was hanging lots of dozens and dozens of tulips in the air, that was very large. I also work with municipal government projects. So for example, there was this one project that I worked in Japan where we connected there was an opening of a highway tunnel that connects the entire Tokyo region, and there was an opening event which I was asked to create a large-scale installation using that huge highway tunnel that has been under construction, for decades. And we used the AI and IO technology to connect inside the tunnel with nature in Mount Fuji. Mount Fuji is probably is the highest mountain in Japan, to connect the nature and wildlife outside of the tunnel and feeding that sound and visual inside the tunnel, and then also allowing an back and forth interaction from inside to outside. And that was a huge project with regards to scale. And I think BioArt is not just about microscopic technology, but also about the entire ecosystem and the environment and the society, and how can we bring that all together. So I think that was probably the largest project or installation that I've worked on.
Okay. Another question, what first inspired you to combine biology and art? So you talked about that you love biology since you were a child, but yes, what was the first trigger for you to combine art and biology?
So yes, as I mentioned before, I've always loved nature and science, and at the same time I also liked art as well, but I was not sure how they can be combined. When I was studying in a lab, I was actually studying to become a very serious maybe pharmaceutical researcher. But as I was studying all of the specimens, I became more and more intrigued in how beautiful they were, and wondered if there are any other creative applications to this technology. And I think that is when I started to think about the possibility of maybe combining the two. I wasn't sure until one gallery in Japan asked me to do more of a comprehensive exhibition based on biological materials or cultivating different types of organisms. And when I had that show, the gallerist and I also were not sure that it would be accepted by the public, but it turned out there were a lot of people who came to the gallery who were very interested and visited our gallery with people from all kinds of backgrounds, like science, art, design, or people who just like plants or gardening who would come over. And I think at that point I gradually started to realize maybe there is something here and maybe we can expand this further.
There is another question in this field. How do people react to your work?
Yes. So in the beginning, people were kind of surprised, I think, and wondered, like, why are these two things, biology and art, combined to begin with? And I think a lot of the question that is about, like, why did you start to combine these two fields? So many people are surprised, but at the same time, I was surprised that a lot of people actually accepted this very naturally, in a way, especially children, because children still don't distinguish between what is science and what is art and what is natural and man-made, and they're like masters at combining all of that and playing with it. So I think there are a lot of things that people can instinctively understand when they experience this beautiful world when they are combined.
Okay, so different reactions, especially from the different ages.
Yes.
Another question from YouTube: how do you manage to combine the biology and art? So what's the creative process, so to say?
So there are so many, like almost infinite number of natural phenomenon occurring around us all the time, and I'm always very interested and curious about each one of them. And I try to take notes on all of them, and I do still like to collect seeds, for example, like pick things up from the streets in the mountains. When I go jogging, I sometimes end up coming back like with a twig or a leaf in my pocket, which I collect. And so I think basic research is always very important. So everything that you see that is happening around you, I think can be used as a clue to create installations or new technologies or new artworks. So it's important, I think, is to take notes of all of that and try to research on all of them, but gradually narrow them down into specific items, projects that you think might be feasible at this time. Some of them you might just want to keep for long-term research. Some of them you might be able to execute or turn into an installation very quickly. So after that, I would usually create different types of prototypes, most of the time you fail. I fail all the time. So I think experimentation is very important. And in the end, creating an installation and also working with exhibition venues and galleries so that they are in the end installed safely and exhibited safely, as well as uninstalled and treated properly in the end as well.
That's the next question, is really linked to this, to your answer. How do you preserve this kind of art for the future, or can you preserve it for the future? With paintings and statues, it's pretty straightforward, but what's about bioart? How you can preserve it, or is it an art form you want to preserve for the future?
That's a very, very good question, and that's the debate that I always have, like galleries, for example. So if you are exhibiting in a commercial gallery, for example, I think the gallery, they try to, like, usually artists sell their works, which means that the collectors must be able to safely collect your work and preserve it, or same as for museums. I think in my case, I have tried to, I do have some series of projects where it can be preserved for a long time, and I do try to preserve some types of projects, but I think you raise a good point in that, should it be preserved? Like, if it's alive, should it actually go through a cycle of being born, living, and dying as well? Because the entire cycle itself, there's a beauty in that cycle. And so maybe it should not be forever. Maybe it should be something that you see in that moment that you meet, like you meet an organism or you meet another person. So maybe it's that, like, one moment, one time in a life, one moment that you share together. Maybe there's a beauty in that part. So some installations I regard as more of a co-performance with other living things. So it's more like a performance during that exhibition where everything is alive, but after that it's a performance. So we go home and then we perform again in the next exhibition.
Okay. Yeah, really interesting to think about it, as we have the Ars Electronica archive as well.
Yes.
So of course we're thinking about the things the same way. Okay, you can make a video or something like that, but this is not really preserving it. It's
right. But I do agree that it's very important to archive these types of projects. Shooting like beautiful footages and images, I think, are always very important.
Another question, what aspect of nature do you love working with most, and why?
I like working with plants the most, and I guess I respect them in that they support all of the living things in the food chain, and they are not just beautiful by itself on its own, but has all these chemical reactions that they are kind of controlling very accurately for them to kind of adjust themselves with the environment, but also to communicate with each other and communicate with the environment. And that is one area that fascinates me, because plants can do so many things that humans cannot do, and I just love working with them.
Maybe a good link for our next question from YouTube. Is there anything in biology or biotechnology that you won't work with because it's too controversial?
That's a very, very good question as well. Because I like living things so much, and nature so much, and that's how I started as a researcher. So I tend to not like hurting living things. I do not like experiments that may hurt living things. When I was in a biolab, I did have a lot of difficulty working with mice, for example, rats and mice, or lots of living things are used in experiments, which it would break my heart every time, and I just could not. So those are some of the things, like things that may hurt in a living thing, or that has the possibility of hurting or disrupting an organism or the ecosystem, is something that I'm always concerned about, and probably.
What is your personal opinion about CRISPR and all these technologies? Is this what you are interested to work on, or you say no, this is too far for?
Actually, CRISPR and latest technologies, I guess as a technology, I am always very, very interested in how they work. I guess the way that you use them and the application, I would probably be very, very careful of. But as a technology, I think it's very, very interesting, and would definitely be interested in working with all types of emerging technologies. But I think it's always, for me, important how we use them properly, and is it good for the advancement of human civilization, or for humans, but also for all living things on Earth?
That's a really good question I have a final question here. For the future, what is the next big thing that you are working on?
So I think I mentioned briefly in our presentation, I'm very, very interested in space. Going outside of Earth, because I think that might be our next adventure, exploration into the unknown. Will we find living things, or just by us going out there, there are so many natural or phenomenon that is very different outside of Earth in the space. So I'm very interested in working with researchers in other countries currently to collaborate on a lot of space projects. So I think a lot of people may not link biology with space, but I think that might be one of the most interesting areas to work in the next decade.
Wonderful. So I think we have no question left. Thank you very much for this talk.
Thank you very much.
It was really great to have you here, Yoko. Thank you for this great dive into BioArt and your research. If there are questions in the next days or weeks, of course, you can post them, or you can write it per email at home.delivery@ars.electronica.art. And Yoko, if you're maybe you can post some links to the video that you can follow it up a little bit. And yes, hopefully we can open the museum soon, so you can visit us here in the BioLab.
Yes.
Maybe meet Yoko while she's working here. And yeah, next week, next Tuesday again at 1 o'clock inside Futurelab, there we will meet Otto Naderer, and he will talk about laser tracking in the deep space, another really great research field from our friends from the Ars Electronica Futurelab. Thank you very much for watching, and have a good evening, good afternoon, of course.
Thank you, everyone. Bye.
Bye-bye.